Okay, Faria. So last class, what we have studied? Can you remember?
Yes, sir.
What we have studied last class?
The adsorption, we have read adsorption isotheorem, the different types, type 1, 2, 3, 4, 5, and 6, and then application of adsorption theorem in solid liquid interface, then weighting phenomena, and its application.
Okay. Yeah, I think last class we have studied this one. Okay, different types of adsorption isotherm.
Yes, sir.
Type 1, type 2, type 3, type 4, and type 5. And Langmuir adsorption isotherm. Okay, Friendlich isotherm. Already we have completed this one. So today we will study about another one new topic of this chapter only, interfacial phenomena, that is electrical properties of interface. Electrical properties of interface. So on the first day of this chapter, first definition it was that what is interface. Can you remember what is interface? What is interface? Anyone?
Sir, it's the surface area different surface area between two immiscible substances, like two immiscible liquids, like that.
The boundary in between two phase, that is known as interface. Right? Very simple definition, that is the boundary in between two phase, that is known as interface. Now uh, the topic name is electrical properties of interface. Electrical properties. What is the meaning of that? Electrical properties. That means interface that will uh, hold some charge. Now, what are the reason behind this? For example, when solids are dispersed in a liquid, in cases of suspension, solids are dispersed in a liquid. Suspension means solids are insoluble in liquid. Okay. If it is soluble, then we can say that it will form a solution. But if the solids are insoluble, then it will form a suspension. So when solids are insoluble, solids are dispersed in a liquid, what will happen? A large solid liquid interface is obtained, which may become charged. Here, now the origin of this charge. What is the origin of this charge? What I told, when solids are dispersed in a liquid, a large solid liquid interface is obtained, which may become charged. Now the question is, what is the reason behind this charge? Okay, so for that you have to know first what are the meaning of electrical double layer. And here see that one picture is there, just look at that picture. From that we will study that what are the origin of that charge which will uh, obtained from the interface, solid liquid interface or solid solid interface. Okay, different reasons may be there, because of presence of electrolyte, because of presence of different types of functional groups. Okay, and difference in dielectric constant, different reasons are there. Okay, electrolyte which are present in solution, or functional group present on the surface of that particle, and difference in the dielectric constant. So like that, different reasons are there for that the charge that will be present on the interface. That may be solid liquid interface, that may be solid solid interface, like that. So what is the meaning of electrical double layer? The concept of electrical double layer that can be described by this picture only. Here also, the solid particles are dispersed in an aqueous solution, and that aqueous solution contains an electrolyte. So what is the meaning of that electrical double layer? See that it occurs between ions or molecules in solution and electrode surface. Electrode, when that are dipped in a solution, electrolyte solution, electrode means anode or cathode, anode and cathode. When that are deep into the aqueous solution which contains some electrolyte, on the surface of that electrode, some charge that will produce. So when electrode that are dipped into the solution containing electrolyte, there is a strong attraction between the both. Okay, strong attraction between electrode surface and the electrolyte ions or molecules that are present in that solution. So it uses to visualize the ionic environment in the charged surface. In this case, all these ion that will distribute surrounding the charged surface. Therefore, it increases the concentration of counter ions. Okay. For example, liquid droplet, solid particle, gas bubble, all uses as object. Now, before starting the actual meaning of electrical double layer, first you have to know what is the meaning of that electrode, what is the meaning of electrolysis, what is the meaning of electrochemistry. First you have to know. So all the molecules or particles, they carry out a electric charge due to their properties. Now the question is, what type of properties? Physicochemical properties. Now what is the meaning of electrochemistry? Electrochemistry and the surface and colloidal chemistry that can be combined with this phenomena. In the next semester, we will study one new chapter, that is colloid. So the stability of this phenomena. Okay. So the stability of colloid, that is completely depends on this phenomena, that is electrical double layer or charge that are present on the surface of that electrode, or in cases of solid surface, the charge present on the solid surface and liquid interface. So what is the meaning of electrode? Electrode is an electrical conducting material which is divided into two parts, anode and cathode. Electrolysis, what is the meaning of that? Electrolysis is defined as the decomposition of substance by means of the electric current. Redox reaction, it was pushes to the non-spontaneous side. Example. Next, after that, substance, electrolyte. What is electrolyte? Substance that produce electrically conducting solution when dissolved in a polar solvent. Solution is considered as the neutral solution. So what is the meaning of electromotive force? Electromotive force described as the cell potential, the potential energy difference between two cell or electrode. Okay, the potential energy difference between two cell or electrode, that is known as electromotive force. So what is electrode? What is the meaning of electrolysis? What is electrolyte? And what is electromotive force? I think all of you cleared about that. These are purano jinis. Already all of you have studied that what is the meaning of electrode, what is the meaning of electrolysis, what is the meaning of electrolyte and electromotive force. So from this electrical double layer, we can describe electrochemistry. What is electrochemistry? Study of reaction in which charged particle crosses the interface between two phases of matter, such as interface between a solid and a liquid. Okay, that is known as electrochemistry. So this electrical double layer, that is a part of electrochemistry, and through this theory we can describe the stability of colloid as well as the stability of emulsion and suspension. So first we will uh, study what will be the applications of these electrical properties of interface. The study of these electrical properties of interface is having so many applications, especially for the formulations of dosage form, stabilization of colloidal dispersion, preparation of flocculated suspension, and stabilizations of emulsion. These three chapters that you have to study in fourth semester, that emulsion, suspension, and colloid. So through this theory, we can describe the stability of colloidal dispersion, flocculated suspension, and stabilization of emulsion. Now, what is the theory behind this? When any electrode that are immersed in an electrolyte solution, the charge accumulation will occur, and particle size that should be greater than 1 nanometer. In this case, charge separation always occur at the interface of the electrode in that particular electrolyte solution. The excess charge on the electrode surface, that is accumulated by an accumulation of the excess ion of the opposite charge in the solution. Sorry. So when electrodes that are deep into the electrolyte solution, charge separation always occurs at the interface of the electrode. The excess charge on the electrode surface, that is accumulated by an accumulation of the excess ion of the opposite charge in the solution. প্রত্যেকটা লাইন ভালো করে বোঝার চেষ্টা করবে। Okay, try to understand every line and every point. It's very much important, electrical properties of interface. So when electrode immersed in an electrolyte solution, the charge separation always occur at the interface of the electrode in the solution, and the excess charge on the electrode surface, that is accumulated by an accumulation of the excess ions of opposite charge in the solution. Okay. So charge will produce at the interface. Now the question is, what is the origin of this charge? So the origin of the charge, first reason is electrolyte present in the solution, they may get adsorbed on the solid surface. If ions are absent, the vehicle, that means water, that may dissociate into two ions, hydronium ion and helium ion. After dissociation, they will get adsorbed. Sorry. Adsorption of hydroxyl ion are most common because of the asymmetric nature of the hydroxyl ion. And second reason is functional group such as carboxyl group present on the surface of the particle that may also get dissociated, and it also impart a charge. For example, carboxyl group, NH2 group on the protein that get ionized. Okay, so already I told this one, that presence of electrolyte. Next, second one is presence of functional group. Example of functional group, that is carboxyl group and NH2. And another one reason for this origin of charge, that is difference in the dielectric constant. Okay, difference in dielectric constant between the particles and the dispersion medium, that are responsible for the origin of charge through a less common source. Okay. Just a minute. Huh. So the three reasons are there. Presence of electrolyte. Second one is presence of functional group like carboxyl group and NH2 group. And third reason is difference in the dielectric constant between the particles and dispersion medium that are responsible for origin of the charge through a less common source. Now, the charge on the solid surface, what already produced, that impart certain change to its environment regarding the distribution of ions. That means in the solution, all that ions, cation and anion, how they will distribute throughout the electrolyte solution, that can be described by electrical double layer. Okay. So this is the schematic diagram of electrical double layer. And here we can see one interface. In this case, what is that interface? Can you point out? In this picture, where is the interface? Hello, anyone? In this picture, where interface is present?
Sir, A dash.
Yes, very good. A dash.
Hello.
Yes, yes. A dash. So A dash, that is the solid liquid interface. For example, one electrode that are deep into one electrolyte solution. So this is electrolyte solution where different ions that are distributed. See that anion, cations both are present and that are distributed throughout the solution. And this is the solid surface. And this is A dash where cations are attached. This is known as solid liquid interface where all that cations that are attached. Okay. B dash. So here is already written, see that A dash solid liquid interface with potential determining ion. What is the meaning of that? Potential determining ion. Cations are known as potential determining ion. Just see that picture very carefully. Okay, you have to, when if questions may come that write a short note on electrical properties of interface or electrical double layer, write a short note on electrical double layer. So you have to draw this picture. So just point out very carefully all the point regarding this electrical double layer. Now the interface A dash, that is the solid liquid interface. All the cations that are assumed to be present in the solution, all these cations are adsorbed on the solid interface. So this solid interface that impart positive charge or negative charge, when all the cations that are assumed to be present in the solution, they will get adsorbed on the solid interface and they will impart a charge. So that charge will be positive or negative?
Sir, positive charge.
Yes, very good. That will impart a positive charge. All these cations are referred as potential determining ion. You have to remember this. All the cations that are known as potential determining ion, which will adsorb at the solid liquid interface. Okay, next one. So A dash, after that B dash, next C dash, after that D dash. কতগুলো লেয়ার আছে দেখো, just see how many layers are there. A dash to B dash, then B dash to C dash, then C dash to D dash. Next, immediately adjacent to this interface A dash, one region is there from A dash to B dash. This region is known as tightly bound layer. What I told? Just adjacent to the interface, one region is there, this region. Okay. Are you able to see that cursor? Mobile cursor দেখতে পাচ্ছ?
Yes, sir.
So from A dash to B dash, this region is known as tightly bound layer. Okay. Now this tightly bound layer extend up to B dash. Now, when adsorption of cation on the interface is complete, see that interface that is saturated with that cation. So when adsorption of cation at the interface is complete, then what will happen? All that cations attract a few anion. Just see, all these are anions. After complete adsorption at the interface of cation, what they will do? They will attract a few anions and repel the approaching cation. Okay. Further, thermal motion tends to produce equal distribution of ions in the solution. This is the normal phenomena. One electrolyte solution is present, so all the ions that will be equally distributed in the solution. So all cations and anions, they tend to produce equal distributions. So what will happen? At equilibrium, just listen carefully. At equilibrium, some excess anions are present in this region. Okay. At equilibrium, some excess anions that are present in this tightly bound layer. However, their number is very much less than the adsorbed cation. The number of anion that are present in the tightly bound layer that are less than the adsorbed cation. Therefore, B dash that is still possess positive charge. Up to this, all clear? All of you are getting my point? Hello? Up to this, all of you clear about this?
Yes, sir.
Yes, sir.
So, okay. So A dash, that is solid liquid interface, that is known as and in this region potential determining ions are present. All the cations that will adsorb at the solid liquid interface. Because of this interface that impart a positive charge. Okay. Once the adsorption of cation at the interface is complete, the cations attract few anions and it will repel the approaching cation. Further, the thermal motion which tends to produce equal distribution of ion in the solution. But the number of anion that is less than the adsorbed cation. Because of this reason, B dash that still possess positive charge. Why? Because the number of cations that are more than the number of anions present. Because of this reason, B dash that also possess positive charge. Now, anions are another one term that is used for anions. Anions are also termed as counter ion or Jejenian. What I told? Cations are known as potential determining ion that are adsorbed at the interface. Same, anions are termed as counter ion or Jejenian. G-E-G-E-N-I-O-N-S, Jejenians. When particles move relative to the liquid, this tightly bound layer also moves along. Thus, the particle surface now extend up to BB dash rather than AA dash. So the boundary BB dash, that is also known as shear plane. Because of that, here I have written, see that BB dash, that is known as shear plane or solvated layer. Why? Because particle surface extend up to the BB dash rather than AA dash. So this boundary BB dash, that is termed as shear plane. Okay. So AA dash complete, BB dash complete. Next, third layer, BB dash to CC dash. BB dash to CC dash, this layer is known as diffusive second layer. What I told? This layer is known as diffusive second layer. This region is bound by the line BB dash and CC dash. This region, that is known as diffusive second layer. In this layer, excess amount of anion, that means negative ions, that are present. In the second layer, this one, A dash to BB dash, what we have seen, the number of cations that are more than the number of anions. But in this region BB dash to CC dash, the number of anions that are more than number of cation. This layer is known as diffusive second layer. Okay. Now, at and beyond CC dash, the distribution of ion is uniform. That means CC dash to DD dash. In this region, the distribution of ion is uniform. So on the whole, now if we determine on the whole system, in this whole system, the system is electrically neutral. How it is possible? The distribution of ion is unequal in different region. We have seen that in this region AA dash to BB dash, the number of cations is more. In BB dash to CC dash, the number of anions is more. And beyond that CC dash, here the distribution of cation and ions are same. But if we consider the whole system, that whole system is electrically neutral, although the distribution of ion is unequal in different region. So the electrical double layer, we can see that consists of tightly bound layer, that is A dash to BB dash, and diffusive second layer BB dash to CC dash. Now BB dash, this region B to B dash, that possesses negative charge. It indicates the number of anions is more compared to the number of cation adsorbed at the interface. However, that CC dash, that is still maintain electrical neutrality as mentioned earlier. Already I have mentioned earlier that the distribution of cations and anions that are same in the region of CC dash to DD dash. Because of this reason, this CC dash, that will be electrically neutral. Okay, that will maintain electrical neutrality. But BB dash, that may possess negative charge. It indicates the number of anion is much more compared to that the number of cation adsorbed at the interface. Okay. Now, when the interface is adsorbed by negative ion, when the interface is adsorbed by negative ion, then AA dash assume negative charge. if this A dash in this region interface, if anions are adsorbed, then we can say that A dash that assume negative charge, and if A dash negative charge it possesses, then we can say that B dash possesses negative charge, and C dash that will be neutral. Okay, so on the similar line, depending on the distribution of ion, A dash can be negative, B dash may be positive, and C dash that will be neutral. Okay, so when we move from the interface A dash towards the bulk of dispersion D dash, the potential that will change, and that can be represented by this picture. ওকে, তাহলে প্রত্যেকটা জিনিস পরিষ্কার হলো সবার কাছে? অল অফ ইউ আর ক্লিয়ার অ্যাবাউট A dash, B dash, C dash and D dash. Tightly bound layer, first one is interface, solid liquid interface, next tightly bound layer, then diffusive second layer. Okay, now everything what I told that are written here, see that solid liquid interface with potential determining ion. Just try to remember. Consider the solid particle in a suspension which prefer to adsorb positive ion on its surface in an aqueous solution which containing both positive and negative ion due to dissociation of salt. Okay, now which adsorb on the surface that are called potential determining ion. This potential determining ion influence the distribution of ions in the solution around the suspended particle. The positive potential determining ion will repel the other positive ions in the solution and it attract negative ion towards it. Already I told, just remember that at the interface all the cations that will adsorb and the positive potential determining ion will repel the other positive ions in the solution, and they will, after saturation of that interface, solid liquid interface, what they will do, they will attract negative ions. And tightly bound layer with counter ion. This tightly bound layer, that is also known as Stern layer, STERN. This layer is immediately just adjacent to the surface. Here the negative ions will attracted and held close to the solid surface. These negative ions are called counter ions or Jejenions. Just remember, the negative ions are called counter ions and Jejenions, and the positive ions are called potential determining ions. So the number of anions that are less than the adsorbed cation. Thus, this layer possesses positive charge. Just remember. But the thermal motion also will try to the equal distribution of the ion in the solution, obviously. So when particles move relative to the liquid, the tightly bound layer also move along. Thus, particle surface extend up to B dash rather than A dash. Already I told. So the boundary B dash is called C dash. Okay. Next, B dash to C dash, that is known as diffusive second layer. In this area or in this region, concentration of anion will be more than cation. Okay. Concentration of cation increases as moves to CC dash. Now, cation and anion that will be equal at CC dash. So this point is called electroneutral region. Okay, so tightly bound layer, diffusive second layer, then electroneutral region. Okay, then Stern layer and GO layer, B dash to C dash, both together called electrical double layer. The name of this theory we are discussing about, that is electrical double layer. So why it is called electrical double layer? Because of A dash to BB dash, that means Stern layer, and BB dash to CC dash, that is also known as Gauss layer, together called electrical double layer. Okay. Next, the most important, Nernst potential, that is described by capital E. Nernst potential. What is that Nernst potential? It is the potential of solid surface itself. In this case, solid surface means which one? Nernst potential, that is the potential of the solid surface. In this case, what is that solid surface?
Sir, the interface.
AA dash.
A dash. Yes, A dash interface. So Nernst potential, that is the potential of solid surface itself, that is A dash, owing to the presence of potential determining ion or cation. So this Nernst potential is also known as electrothermodynamic potential. Electrothermodynamic potential. So what is the definition of this Nernst potential? That is capital E. It is the potential difference in between the actual surface and electroneutral region of the solution. Try to understand. Nernst potential or electrothermodynamic potential is defined as the difference in potential between the actual surface and electroneutral region of the solution. Again, I am repeating, the potential difference between actual surface and electroneutral region of the solution. That is known as Nernst potential. So this is Nernst potential. Another one definition is there, that is known as zeta potential. So zeta potential, what is the meaning of that? Zeta potential, it is the potential observed at the shear plane. Zeta potential that is observed at the shear plane. So just remember the picture. In that picture, what is the meaning of shear plane? A dash, BB dash, CC dash, or DD dash? Which one is shear plane?
BB dash.
BB
BB.
dust.
Or BB dash.
Very good. So zeta potential, it is the potential observed at the shear plane, that is BB dash. Okay. Zeta potential, that is also known as electrokinetic potential. Okay, try to remember. Zeta potential is known as electrokinetic potential. It is defined as difference in potential between the surface of tightly bound layer, that means shear plane, and the electroneutral region of the solution. What I told? Zeta potential or electrokinetic potential is defined as the difference in the potential between the surface of tightly bound layer, okay, tightly bound layer, and tightly bound layer, that means shear plane, BB dash, okay, BB dash to the electroneutral region of the solution. Or also we can define this zeta potential in another way, that is work required to bring a unit charge from infinity to the surface of the particle. Again, I am repeating, zeta potential can also be defined as the work required to bring a unit charge from infinity to the surface of the particle. So two definitions I told. Again, I am repeating, very important this one. zeta potential and Nernst potential, especially zeta potential. So zeta potential kinetic potential is defined as the difference in the potential between the surface of tightly bound layer, that means shear plane, and electroneutral region of the solution. This is one definition. Another one definition is that is work required to bring a unit charge from infinity to the surface of the particle. Okay. So this zeta potential can be determined by using an electrophoretic cell or zeta meter, that is also known as zeta sizer, based on the moment of particle under the influence of electric field. Okay, I told one name of instrument, zeta meter. Zeta meter, that will we can determine only the zeta potential value, but zeta sizer, that is very much important instrument, that is zeta sizer. Zeta sizer, by using this instrument we can determine particle size as well as zeta potential value. So by determining zeta potential value, microemulsion or nanoemulsion, and stability of suspension and stability of colloid. So from the value of zeta potential, we can determine the stability of emulsion, suspension, and colloid. And also, we can determine the particle size in cases of suspension and colloid, and globule size in cases of emulsion. So, just আমি এখনো মনে করতে পারি আমার পিএইচডির সময় একটা স্যাম্পেলের যেটা পটেনশিয়াল আর পার্টিকেল সাইজ ডিটারমাইন করার জন্য একটা স্যাম্পেলের জন্য আমার চার্জ লেগেছিল 500 রুপিস। ঠিক আছে, নাও ইট ইজ অলমোস্ট মোর দেন 1000 রুপিস required to just determine the determinations of particle size and zeta potential value. Okay, so very much costly instrument, 36 lakhs the price of zeta sizer. Okay, so one company is there, the name of company is Malvern. So that's why that is also known as Malvern zeta sizer. If you use this instrument, so you have to pay more than 1000 rupees for one sample, only for determination of particle size as well as zeta potential value. Okay, so this is all about zeta potential and Nernst potential. See that the potential energy will be the highest at the surface and it will decrease sharply along the stern layer and gradually along both. Okay, see that, just see that figure, so you'll be able to understand what is the meaning of zeta potential, what is the meaning of stern potential, and what is the meaning of surface potential. Different layers are there. This is tightly bound layer, then diffusive second layer, this is diffusive second layer, and after that are present, that anions and cations that are equally distributed, and particles with negative charge that are present inside. See that, and here the charge distance from particle surface distance. See that, up to this, that is zeta potential, up to this turn potential, and up to this, that means this one, that is surface potential. So this zeta potential, that is one of the most important characteristics from which we can determine the stability of emulsion, suspension, and colloidal dispersions. Okay, so uh, up to this, that zeta potential and this one Nernst potential, এই পর্যন্ত যেটা আজকে পড়ালাম, just try to understand, and everything that I have taken from this one Martin physical pharmacy, so just go through it and try to understand. And when you will practice it, just tightly bound layer and diffusive second layer, and after that try to write that what is the meaning of that tightly bound layer, diffusive second layer, and what is the meaning of Nernst potential and zeta potential. Okay, so any question? সবাই আছো তো নাকি ঘুমিয়ে পড়লে? হ্যালো,
Yes, sir.
সবাই বুঝতে পেরেছো? নো ডাউট? কোনো অ্যান্সার নেই? গিভ মি অ্যান্সার। সবাই বুঝতে পেরেছো? সবাই চুপচাপ আছো মানে আমি এটুকু ধরে নিলাম সবাই বুঝতে পেরেছো। নো ডাউট, তাই তো? আরে আমি
হ্যাঁ
তোমাদের
স্যার, মোটামুটি ঠিক আছে। হ্যালো স্যার, হ্যালো।
হ্যাঁ রেসপন্স তো করো। হ্যাঁ আচ্ছা, তাহলে বলো তো আমি একজনকে তাহলে একটা কারো যখন ডাউট নেই তাহলে আমি জিজ্ঞেস করি। ওকে জিজ্ঞেস করব। মৃন্ময় শুনতে পাচ্ছ? মৃন্ময় পাল।
Yes, sir.
হ্যাঁ মৃন্ময় বলো, হোয়াট ইজ জেজেনিয়ান? হোয়াট ইজ দ্য মিনিং অফ জেজেনিয়ান? পৌলমী ঘড়ুই, পৌলমী
Yes, sir.
টেল মি হোয়াট ইজ দ্য মিনিং অফ জেজেনিয়ান?
Sir, পারবো না।
কেউ পারবে?
হ্যাঁ স্যার পারবো।
Another term of anion is zirconium.
স্যার টাইটলি বাউন্ড লেয়ারে যে অ্যানায়ন গুলো থাকে, মানে যেগুলো কাউন্টার আয়ন বলা হয়, সেগুলোকে জেজিনিয়ান্স বলা হয়।
Yes, that means jejenian means ions having a charge opposite to the potential determining ion. তাই তো? Jejenian means ions having
Yes,
a
sir.
charge opposite to the potential determining ion. আচ্ছা শোনো, ক্লাসটা এখানেই শেষ করলাম। আজকে ফার্স্ট টাইম তোমরা এইটাতে গ্রেট লার্নিং এ ক্লাস করলে। একটা জিনিস মনে রাখবে, এখানে যেমন দেখো তোমরা যখনই জয়েন হলে মেল আইডিতে চলে গিয়েছিল সবার, হয়েছে তো? তো যখন জয়েন হয়েছো আর যতক্ষণ থাকলে ওটা কিন্তু এখানে পুরোপুরি অ্যাটেন্ডেন্স অটোমেটিক্যালি এখানে কাউন্ট হয়ে গেছে। ঠিক আছে, কতক্ষণ ক্লাসটা করেছো, কে কে করেছো, এভরিথিং অল আর রেকর্ডেড। আর এই ক্লাসটা কালকে ধরো আজকে আমরা এখন 10টার সময় শেষ হলো, 10:30, তো এরপর কালকে 10:30টার পর আফটার 24 আওয়ার্স তারপর তোমরা এটা রেকর্ডিং দেখতে পারবে। ঠিক আছে, রেকর্ডিং গুলো ওখানে থাকবে। রেকর্ডিং যদি তোমাদের মনে হয় যে বুঝতে অসুবিধা হচ্ছে তাহলে রেকর্ডিং গুলো তোমরা আবার দেখতে পারো, ওখানে রেকর্ডিং গুলো সবকিছু ওখানে ক্লাউডে থাকবে। ঠিক আছে, তো সেই কারণে কোনো অসুবিধা নেই, কিন্তু সবাই আচ্ছা সেই জন্য আমি আলাদা করে আর কোনো রকম এখানে কোনো লিঙ্ক বানাইনি অ্যাটেন্ডেন্সের জন্য, এখানে সবকিছু এখানে অটোমেটিক হয়ে গেছে। আর আজকে কোনো আমি কোশ্চেন দিইনি, পরের দিন আমি কোশ্চেন দেবো। ঠিক আছে
স্যার, কোশ্চেনটা কিভাবে দেবেন পরের দিন?
দিস ওয়ান গ্রেট লার্নিং। যেমন আগে কি করতাম আমি, আগে তোমার আমি ওই গুগল ফর্মে কোশ্চেনটা বানিয়ে সেই লিঙ্কটা তোমাদের শেয়ার করে দিতাম, তাই তো?
হ্যাঁ স্যার।
এখন হ্যাঁ, এখন এটাই দেখবে গ্রেট লার্নিং এই তোমাদের কোশ্চেন কিভাবে হয় তোমাদের আশা করি কালকে তোমরা সবাই যেটা অ্যাটেন্ড করেছো ওয়ার্কশপটা ওখানে বুঝিয়ে দিয়েছে। তো সেম এখানেও যেমন এখানে ধরো মেল চলে গেল, তেমনি এটাও যখন কোশ্চেনটা হবে ওখানে তোমাদের মেল চলে যাবে এবং ওখানে তোমরা দেখতে পাবে কোশ্চেন গুলো যেমন আগে দেখতে সেরকম।
স্যার,
হ্যাঁ
স্যার কোশ্চেন আপলোড করলে কোনো মেল আসে না।
কি করে বুঝলে?
স্যার কালকের আনন্দময় রুদ্র স্যার রাত্রে কিছু কোশ্চেন দিয়ে দেখছিলেন, মানে স্যার দেখছিলেন যে কি করে করতে হয়। তো আমরা যখন ওই আপনাদের লিংক গুলো আসে তখন যখন খুলে দেখি ওখানে কোশ্চেন দেওয়া আছে, কিন্তু কোশ্চেনের কোনো স্যার মেল আসেনি।
না
আচ্ছা
কিন্তু আজকে আবার এসেছে একটা মেল।
হ্যাঁ
আচ্ছা
স্যার, মেলটা আজকে সকালে এসছে, মানে কালকে স্যার যেটা দিয়েছিলেন ওটা আজকে
হুম
সকালে মেল।
ও না না, ওটা কি বলতো, স্যার হয়তো যে টাইমটা যেটা ফিক্স করবেন সেই সময়ই কিন্তু তোমাদের সবার কাছে যাবে। মনে আছে তোমরা যখন সিএ গুলো দিচ্ছিলে, সিএ গুলো যখন আমি এখান থেকে অ্যাসাইন করব, যেমন ধরো পরীক্ষা ছিল কটা, 10টা থেকে 11টা বা 11টা থেকে 12টা, তো অ্যাসাইন আমি আগে থাকতেই করে দিলাম যে 11টার সময়। ঠিক আছে, যখনই ঠিক 11টা বাজবে ইমিডিয়েট তোমাদের কাছে অ্যাসাইন হয়ে যাবে। মনে আছে পরীক্ষার সময় যেটা হতো সিএ গুলোর সময়? তো এখানে
হ্যাঁ স্যার।
ওরকম হ্যাঁ ওরকম এখানে টাইম ফিক্স করা যায়। তো স্যার মনে হয় যেটা যে সময় সময় তোমরা পেয়েছো, টাইমটা সেই সময় ফিক্স করেছিলেন, তাই তোমরা ওই সময় কোশ্চেনটা পেয়েছো। তো এখানে টাইম যেটা আমি ফিক্স করে রাখবো সেই টাইমেই তোমাদের কাছে ওটা ডেলিভার হবে। এটা হচ্ছে ব্যাপার। তো দেখি ওটা আমিও তো পরের ক্লাসে আমি তোমাদের আহ, যেদিন করবো সেদিন আমিও বুঝতে পারবো। ঠিক আছে, কারণ আমরাও এটা নতুন, তো তোমরাও নতুন। তো দেখা যাক সেদিন আমি যখন করবো তাহলে ক্লিয়ার হয়ে যাবে অনেকটা।
ওকে স্যার।
স্যার আর যে এই মাঝে মাঝে নেটওয়ার্ক প্রবলেমের জন্য লিভ হয়ে যায়, তো তখন কি মানে ক্লাস থেকে তাহলে ওটার কাউন্ট হবে না?
হবে। তারপরে আবার ওখানে দেখাবে যে তুমি এতক্ষণ ছিলে, তারপরে আবার এতক্ষণ এই সময় আবার আউট হয়ে গিয়েছিলে, আবার ইন হয়ে গেছো, এরকম। ওখানে পুরো
ও
একদম পুরো একটা, হ্যাঁ ওটা তোমরা দেখতে পাবে না, ওটা আমরা দেখতে পাবো। ঠিক আছে, কে ক্লাস করেছে, কে কতক্ষণ ছিল, ঠিক আছে, এভরিথিং সবকিছু মানে অটোমেটিক এখানে ওটা হয়ে যাবে। এবং এই যে তোমরা এখন কথা বলছো বা ডাউট জিজ্ঞেস করছো, এভরিথিং দ্যাট ইজ সবকিছু কিন্তু ওখানে রেকর্ডিং হচ্ছে এটা। এবং আমি ওটা ইউটিউব লাইভ করে দিয়েছি, তোমরা দেখতেও পাচ্ছ। ইউটিউব পরে ইউটিউবে ওখানে থেকে যাবে ক্লাউডে। তাই এটা একটা সুবিধা আছে যে তোমাদের ধরো কোনো একটা ক্লাস পরীক্ষার আগে তোমাদের মনে হলো যে হ্যাঁ এই ক্লাসটা একটু ইম্পর্টেন্ট, একটু দেখে নিই আরেকবার স্যার কি বলেছিলেন, তো তোমরা এটা এখান থেকে পরিষ্কার দেখতে পাবে রেকর্ডিং গুলো থেকে।
আচ্ছা।
ঠিক আছে, কিন্তু আজকে যে টপিকটা পড়ালাম কিন্তু খুব 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 ইম্পর্টেন্ট। এটা শুধু আজকে না, ইন ফিউচার তোমাদের যত ধরো যারা এমফার্ম পড়বে বা ইন ফিউচার এই এই আইডিয়াটা কিন্তু লাগবে। হোয়াট ইজ দ্য মিনিং অফ জিটা পটেনশিয়াল, অনেকেই জিজ্ঞেস করে এবং ইন্টারভিউতেও জিজ্ঞেস করতে পারে। হোয়াট ইজ দ্য মিনিং অফ জিটা পটেনশিয়াল এন্ড হোয়াট ইজ ইম্পর্টেন্স অফ, তো ভালো করে টপিকটা পড়বে পরের দিন। আমি আশা করবো যে তোমরা ডাউট কোনো থাকলে বা কোনো কিছু থাকলে আমার সঙ্গে এটা আলোচনা করবে, ডিসকাস করবে। ঠিক আছে, থ্যাংক ইউ অল।
স্যার
হ্যাঁ
বলছি আপনাকে কখন ফোন করা যায়, মানে আপনি একটা ব্যাপারে আপনাকে ইনফিটেল এর ব্যাপারে একবার ফোন করার ছিল, আপনাকে
বলো।
ফোন করছি মানে কেটে যাচ্ছে, মানে তো কিছুবার রিং হওয়ার পরেই কেটে যাচ্ছে, বলছে ব্যস্ত আছে, বলছে যে নেটওয়ার্ক কভারেজের বাইরে
আচ্ছা
আছে।
আচ্ছা, কি প্রবলেম বলো না, আমি বলে দিচ্ছি একটু।
না, এটা আপনাকে ফোনেই বলতে চাই আমি।
আচ্ছা ঠিক আছে, আমি কল করে নেবো তোমার।
স্যার,
হ্যাঁ
এটা নিয়ে আমারও একটু সমস্যা হচ্ছিল, মানে আমি ওইটা খুলতে পারছি না, মানে আমি আপডেট করতে বলতে স্পাম অ্যাপটা আপডেট করার পরে আর সাইন ইন করতে পারছি না।
কেন তুমি মানে ওপেনই করতে পারছো না ইউজার আইডি পাসওয়ার্ড দিয়ে?
হ্যাঁ, দেখছি দ্য সাইট ক্যান নট বি।
না না, তাহলে তুমি ওখানে মনে হয় পাসওয়ার্ড ভুলে যাওনি তো?
না স্যার, আমি
তারপর
ওই ইমেল আইডি ওই পাসওয়ার্ড দিয়ে আমি খুলছি কিন্তু হচ্ছে না।
হ্যালো
একবার
আর
ট্রাই
হ্যালো
করে। হ্যাঁ
ব্যাক
হ্যালো।
করে দেখাচ্ছে
স্যার,
অথেন্টিক।
আমারও সেম প্রবলেমটা হচ্ছে। আমিও দেখলাম যে অ্যাপটা আপডেট করার পরে কোনো কারণে লগ ইন হচ্ছে না। তো আমার একটা
স্যার
অ্যাসাইনমেন্ট
ওইটা
সাবমিট করার ছিল, আমি ওয়েবসাইট থেকে করেছি ওটা, কিন্তু অ্যাপ থেকে খুলতে একটু সমস্যা হচ্ছে স্যার।
হ্যাঁ
আচ্ছা
স্যার,
আচ্ছা
অ্যাপ
আচ্ছা।
থেকে
স্যার
খোলা
ওটা একটা
যাচ্ছে না।
আগের দিন আমি স্যার আমি আগের দিন ওটা দেখছিলাম, দিয়ে যখন ওখানে গুগল দিয়ে গেলাম, তো
হুম
সেখানে আবার অনলি মেলটা শো করলো, মেলটা দিয়ে ক্লিক করলে ওটা খুলে যাচ্ছে আবার।
তাহলে তাই
ওটা
করো, তাই করো,
সাইন
ওটা
ইন না
অ্যাপের।
করে ওই
হ্যাঁ
অনলি গুগল দিয়ে গিয়ে।
হ্যাঁ হ্যাঁ হ্যাঁ, জিমেল দিয়ে গুগল দিয়ে ওটাই সবাই করবে, তার কারণ হচ্ছে
স্যার, আমি
ওটাই
কিন্তু
সেফ।
গুগল দিয়ে খুলিনি, আমি স্যার আলাদা করে ইমেল দিয়ে খুলেছিলাম।
হ্যাঁ তাও করতে পারো, কোনো অসুবিধা নেই, কিন্তু
কিন্তু স্যার আমি যখন লগ ইন করতে যাচ্ছি তখন হচ্ছে না, ওয়েবসাইট থেকে করছি হয়ে যাচ্ছে, কিন্তু অ্যাপ থেকে হচ্ছে না।
হ্যাঁ ওটা অ্যাপের হয়তো কোনো ওদের হয়তো কাজ চলছে বা অ্যাপটার হয়তো কোনো প্রবলেম পারে। ঠিক আছে, সব সময় চেষ্টা করবে যে ওয়েবসাইট দিয়ে করার। ওদের অ্যাপে হয়তো কোনো সময় হয়তো কোনো ওদের প্রবলেম আছে, সে কারণেও হয়তো হতে পারে। ঠিক আছে, তাই ওটা সবসময় ওই ওয়েবসাইট দিয়ে করারই চেষ্টা। ঠিক আছে, তাহলে
আচ্ছা
এখানে শেষ করি।
স্যার, হ্যালো,
হ্যাঁ বলো।
না বলছি যে মানে কখন করলে আপনাকে ধরতে পারবেন একটু
আমি করে
বলতে
নেব
পারবেন?
তোমাকে, আমি করে
আচ্ছা
নেব
স্যার,
তোমাকে। ঠিক আছে।
একটু অন্য ব্যাপারে একটু ইয়ে করার
হ্যাঁ
আছে।
হ্যাঁ হ্যাঁ, ঠিক আছে ঠিক আছে। আচ্ছা
ঠিক
এখানে
আছে,
শেষ করলাম। হ্যাঁ,
ওকে
থ্যাংক ইউ
ওকে
অল।
স্যার। হ্যাঁ স্যার।